Okay. So the question for circuit 1 is for us to determine the current flowing through each of the resistors in the circuit and the voltage drop across 6 ohm resistor. By what? By application of Kirchhoff current and voltage law. So you have already given a clip on how to go about it. This is Kirchhoff law, and you are asked to use both the two laws, the current and the voltage law. So I think it's straightforward. So if you look at the circuit, we have two power sources, two cells, 9 volt and 3 volts. So now we're going to assume our current direction from both the two power sources. So how is it going to be? We're going to assume both 9 and 3 volt cells are contributing to the circuit at the same time. So how is it going to be? Is it up or down? Where do you think we're going to source our current?
So the 9 volt current should be going up.
Should be going up. Good.
Yes, sir.
Like this, right?
Yes, sir.
Yes, so we have reached the junction. So what do you think will happen? At the junction, we're going to have what? When you reach the junction in the circuit, it's either you have a separation of current or what? Margin of current. That's what junction means. It means where current either separate or what? Merge. So we have reached a junction, and in this junction, it's safe to say we have two conductors merging together to what? One conductor. So same as saying you have two current flowing through, coming from two conductors and then to one. So we're going to have our current, according to our assumption, the current coming from 9 volt and the other current coming from 3 volt are going to merge up in junction 1, the upper junction. And then they will both follow through the 3 ohm resistor like this. Remember, this is your second junction. And we don't have to care about it. So we are done assigning our current direction. The next thing to do is to apply our current. Remember, we're going to apply both current and voltage law. So we need to know where our current 1 is, current 2, and current 3, because we have 3 resistors. Therefore, we're going to have 3 currents. So we can choose our current 1 to be 18 ohm, 2 to be 6 ohm, and 3 to be 3 ohm. Okay, so the next thing to do is to apply our laws. But remember, we don't have a loop. So who is going to give us the direction of our loop?
Upwards.
Upward is a little bit confusion. Can you say either clockwise or
Clockwise. Clockwise.
Okay, clockwise. For which loop? Is it for both?
Yeah, for both.
But why do you choose it for both? Because it's Kirchhoff law. We are asked to apply only what? Kirchhoff law. Had it been its mesh analysis, then each of the loop is going to depend on the direction of the positive terminal, right? Or the direction of the current coming from the power source in that particular loop. So now we're going to choose the bigger power source, and then we'll take the loop for both. Based on what? The direction of the loop in the bigger power source. So now what do? Look at the bigger power source. It's 9 volts and it's going upward. So the loop definitely is going to be clockwise in both, right?
Right.
Good. So the next thing to do is to apply our Kirchhoff junction rule for current, which is going to be a single equation, and then the Kirchhoff loop rule for voltage, which are 2 equations. So what do we have as our first equation? Summation of current entering a junction is same as current leaving a junction. So which current is coming in and which current is leaving?
I1 and I2 are coming in, I3 is leaving. I1 and 2 coming in, I3 leaving.
Good. So we have I1 plus I2 equal to I3, right? Equal to I3. This would be our equation 1. And then we're done with the current law. So we can now move to a junction law. Can we choose the loop with, yes, can we choose our left hand loop to be our first loop? So please, based on that, can we state our junction law based on the first loop? Let's start from the 9 volts. So what do we have? Is it positive 9 or negative?
Yeah.
Positive 9. Good. Positive 9, and then we have negative 18 I1, and then we have positive 6 I2 minus 3, the other voltage, all equal to 0. That would be our equation 2. Remember, we're starting from this, and the current is coming from what? The positive terminal. So we have positive 9. And then if you look at the direction of current through I1 resistor, you see that the loop and the current are in the same direction, so we take negative. And then for I2, they are opposing. If you look at I2 and the loop are opposing each other, therefore we have positive 6 I2. And then we have another power source, which the loop is coming out of the negative terminal. So we have negative 3 volts. So is it correct? Hello? Is it correct?
Yes, sir.
Good. So the second equation, can we start from the power source also? If you look at the power source, is 3 volts in that particular, the second loop. And the loop is coming out of the positive terminal. So we have positive 3, and then the other current we have is I2 through 6 ohm resistor. So if you look at the loop and the current are in the same direction, so we have negative 6 I2. And then the next current is 3 ohm, and if you look at I3, the loop are also in the same direction, so we have another negative 3 I3 equal to 0. This is our equation 3. Are we correct? Are we correct?
Yes, sir.
Good. So what do we do next? This is simultaneous equation. I believe you all know what to do next. You have to make, for you to carry out elimination method, then you have to make sure that two of your equations look similar. By similar, meaning they should have same unknown variable, right? Are we okay? So how do we do that? Equation 2 and 3, can we make them look the same? Look similar, I mean. Hello, what do we
Yes.
do? How do we make equation 2 and 3 look similar? By substitution, right?
Yes, sir.
Yes, so which equation are we going to substitute in which one? For us to be able to get or to gain another equation that looks similar. If you look at equation 1, it has all the three unknown variables. So by making I3 the subject formula, we're going to include I3 is going to be replaced with I1 and I2. And that I1 and I2, if substituted in equation 3, definitely we're going to have a new equation with I1 and I2 just as equation 2, right?
Right.
So that we are substituting equation 1 in equation 3. And it's going to be like this. Remember, this is 1, we are substituting in 3, and the equation will be 3 minus 6, I2 minus 3 into I1 plus I2 equal to 0. So this equation, we can reduce it by having, by reduction, we're going to have minus 3 I1 minus 9 I2 equal to minus 3. So we can call this our equation 3, but x, because it's a modified equation 3. Or we can call it, a new equation 3. So now we have an equation that looks similar to equation 2. If you can remember our equation 2, our equation 2 is same as, the simplified form of equation 2 is same as 6 I3 equal to minus 6. So we can call this is our equation 2. Or we can call it the simplified form of equation 2, which can also be known as 2x. So these two equations, we can solve them by elimination method for us to get the unknown. So by elimination, I can say this equation will be multiplied. We can start by eliminating I1 minus 18 and minus 3. And the new equation is going to be, we are eliminating I1, so we don't have I1 anymore. And we're going to have k is going to be minus 18 I2 equal to, for the first one, by multiplying all through by minus 18. Then for the second one, by multiplying all through by minus 3 multiplied by 6, we're going to have 1. Oh, sorry, that was a mistake. Okay, so now we're going to have, it's going to be, by elimination, we're going to have going to have positive 1, 6 to I2 equal to positive 54. And then second equation, we're going to multiply all 2 by minus 3, we're going to have minus 18I2 equal to 18. So remember, we are eliminating minus minus, we're going to have 1ATI2 equal to 36. Then our I2 is now going to be 0.2 ampere. So by substituting for I2 equal to 0.2 in the 2 equations, in any of the 2 equations, we're going to have our I1 as 0.4 ampere. And I3 also from equation 1, if you remember, I1 plus I2 is equal to I3. So I3 is safe to say is addition of I1 and I2, which is going to be 0.6 ampere. So we have I1, I2, and I3. And the next question is to find the voltage flowing through the 6 ohm resistor, which is same as I2. So by making it V2 is going to be I2 R2. So our V2 was found to be 0.2. We multiplied by R2, which is 6 ohm. And we're going to arrive at a value of 1.2 volts. So this is all about question 1. Any problem? This is what I was expecting for equation 1. Sorry, for circuit 1. So anybody with this will have his or her full mark, which is 8 mark for question 1. Yes, 1. So are we okay? Any problem? Can we move forward? Hello, you're not saying anything. Any problem?
No, sir.
Okay, we are okay, right? Okay, so let's take the second question is 2A, and the question was to give one similarity between mesh and branch analysis and one difference between mesh and branch analysis. If you can remember, from the laws you can take their similarity and differences. Remember, for mesh analysis, only from Kirchhoff law alone you can answer that question. From Kirchhoff law alone, because I said all you have to say is yes, there are differences. One of the differences they have is mesh analysis required the application of only Kirchhoff voltage law, while branch analysis required the application of both current and voltage Kirchhoff law. Then the similarity they have is that they both use Kirchhoff law. So I think this is one of, and also you can take the differences I gave you. I gave you so many differences between the two, because when you are dealing with mesh analysis, remember, number of current depend on number of loops. But if it is branch, number of current depend on what? Number of resistors. And secondly, when you have resistor in common, both the loops will be part of your equations. That is for what? For mesh analysis. For branch analysis, when you have resistor in common, you still solve the loops independently without combining the two loops. So there are so many differences that I gave you even during our lecture, which I believe if you have used the ones I gave you, you would have gotten your full 4 marks for that particular question. So the next one is question 2B. Okay, and we are asked to use mesh analysis to find the current flowing through each of the resistors we have in the cycle. We're going to apply mesh analysis by using matrix method, and we're going to use normal elimination and substitution method, so that you have the idea on how to go about both. But you should know that matrix form is more accurate, even though we're going to get the same thing by using the two methods, but it's more accurate because in some circuits or in some equations you find it difficult to use elimination and substitution method. So we're going to start with matrix, and then we'll move to the simpler method. Okay, this is the circuit. This is our circuit. So let's start by assigning our current direction. So remember, we only have one power source, and it's 10 volts. And if you look at the resistors we have are smaller resistors. So the best method to use is to what? To choose one direction of current, not both directions. So had it been we have a very large interval between the voltage and the current, then we would have what? We would have considered choosing both directions. So now we're choosing the positive terminal as our current direction. So it's going to be like this. We have current like this. At our junction, this is our first junction, we can call it A junction. From A junction, we have a resistor of 1 ohm and a resistor of 2 ohms. So which of the resistors do you think current will flow first before the other? Is it through 1 ohm or 2 ohm?
Through 1.
Through 1, good, Isabel. Through 1 ohm because it's the smaller. So we have through 1. So definitely it's going to flow through the other one before it comes down to 2. So we can say that yes, this is how our current is going to be. And remember, at both the two junctions we have, you can call it B and C. At both B and C, definitely you're going to have your current coming downward because you have no other option. And then, or your current have no other option but to come downward. So are we okay with this? Current directions. Omotola. Muhammad Zakaria, are we okay?
Yes, sir. Okay, sir.
Good. Kamil.
Yes, sir.
Are we okay? Victor.
Yes, sir.
Good. So what do we do next? We assign our loop. So who can give us the direction of our loop?
That's clockwise.
Clockwise, yes. We are choosing the positive terminal also. So clockwise is going to be clockwise in all. And now we're going to choose the first smaller loop to be our I1, the second smaller loop to be our I2, and the bigger one to be our I3. So now let's take our equations. From loop 1, we're going to have an equation of this. I want you to cross-check my equation. I don't have time to state my equations together with you. So all I have to do is to write down the equations, and then you cross-check it in 2 minutes or 1 minute, and then we'll move forward. And so we have equation 1 as 1 into I1 minus I3 minus 2I1 plus 1 into I1 minus I2 equal to 0, equation 1. Equation 2 as minus 1 into I2 minus I1 minus 2I2 plus 1 into I2 minus I3 equal to 0. And then our equation 3 is 10. Let me see if you can view the whole equation. 10 minus 1 into I3 minus I1 minus 1 into I3 minus I2 equal to 0. Equation 2 and equation 3. So please, I want you to look at the equations. Are they correct? If they are correct, then we can move to simplifying the equations. Or we can take the simplified form of the equations. So I want you to look at the equations. I'm giving you a minute. Once you are done checking, you can talk, please. Don't leave me, don't stay quiet and leave us hanging.
Yeah, they are.
Okay.
Correct.
Somebody says yes. Who is that person? Is it Omotola or Valerie? Who said yes?
Jemima.
Is Valerie?
Jemima.
Jemima.
Okay. So you sure it's okay? I don't need each and every one of you to cross-check the equations. If two I can do that, then I think we're okay. We can move forward. So is
Yes,
it okay?
it's fine.
Eh?
Yes, okay.
It's
It's
correct.
fine. Good. So the simplified form of these three equations are going to be the simplified form of the equations are going to be, the first one is going to be 0 I1 minus I2 minus I3 equal to 0. Then the second one is going to be I1 minus I2 minus I3 equal to 0. And the third one is going to be I1 plus I2 minus 2I3 equals minus 10. Okay. The simplified form of the three equations, are they correct? Or you cross-check? You may cross-check.
So it's correct.
It's correct. Good. So we can move forward by substituting into our matrix. Remember, this is the equation. It says AX equals to B, where A is our matrix. Our A is our matrix, which is the coefficient of I in equation 1, 0, minus 1, and minus 1. The coefficient of I in equation 2 in equation 2 is going to be 1 minus and minus 1. And then in equation 3 is going to be 1 minus 2. Are we correct?
So I have a question, please.
You have a question?
Yes.
What was your question?
Now, the arrangement, let's say this I1 plus I2 minus 2I3 equals to minus 10 comes first. If you arrange them like differently and you do the matrix, will they give you a different answer from someone else that arranged them this way?
Oh, you mean if your I1 is I2, is maybe if my I1,
If maybe let's say your equation 3 is now your equation 1.
okay, equation 3 as equation 1, while
If
3
it's
as,
now equation 1, if it's pattern,
okay, the pattern, if it changes,
yes. Will they give you different answers? For the matrix now, it will be different. That 0 minus 1 minus 1 will come to the third line.
oh, you are saying if, let's say, for example, from your first, from your circuit, you decide to give your loops a different name,
Yes.
yes, you end up with the same answer, but the answer for your I1 is going to be somebody's I3. Or your
Okay.
answer for I3 is going to be somebody's I2. Do you understand?
Yes, sir.
The answers will be the same, but different. The answers will be swapped. Maybe your I2 is going to be somebody's I3. That's why I gave you a regular pattern. So please, I will advise you to keep choosing the same pattern I gave you. This your I1 should be the smaller loop, followed by the next loop to it, and then the bigger one should be I3. If you have 3 loops, and if you have maybe your loops are of the same size, and they are maybe, let's say we have a rectangular circuit parted into 3, then definitely you're going to have the same boxes, so you can choose any direction. In that manner, is going to be the same. But for
Okay,
a
sir.
bridge circuit, please choose the one I gave you always, so that you will not confuse your lecturer when marking your script. If your question come up in this manner, please use the method I taught you. Are we okay?
Yes, sir, I am.
Good.
Thank you.
Okay, so we can move forward. This is our A. Our X is a 3 by 1 matrix, which is our I1, I2, and I3. You will know. Then our B is our equation, equality, which is also a 3 by 1 matrix. We have 0, 0, and minus 10. So the next thing to do is to make X subject formula, because we are looking for X, which is going to be A inverse of B. So that means we have to look for A inverse and then multiply it with B for us to get I1, I2, and I3. So what do we do next? What do we do next? We find our A inverse. But remember, the equation for A inverse is same as 1 over determinant of A multiplied by the factorial transpose of A. So now we have to look for cofactor and also determinant for us to get the A inverse. So now let's start by one at a time. Let's start by finding the determinant first. So the determinant of A is going to be like this. We have our A as 0 minus 1 minus 1, 1 minus 2 minus 1, and 1 minus 2. So we have to close this. We'll have to take the 0 here and then we close the row and column. 0 into, we close, but remember this is plus minus plus. So we are on the addition side. So we are left with 2 times minus 2 times minus 2, which is 4, minus 1 times 1, which is another minus 1. Then the second one, plus, we have a negative sign, the negative sign plus. sign box. So now we are to take this minus 1 and cancel off the line here. So we are taking our minus 1 here, then we open bracket. We have minus 2 multiplied by 1 equals to minus 2. And then we have minus, then minus 1 multiplied by 1, which is going to be another minus 2. Then the last one is a positive box. We close and we take this and then we cancel the lines here. So minus 1, we open our bracket and multiply 1 with 1, and then minus 1 with 2, we have another minus 1. So this is going to be 0 into 5, minus minus, plus is plus. And then we have minus 2 plus 1, which is another minus 1. And then we have minus plus is another minus. We have 1 plus 2, because minus minus is plus. So we have 3. So this is safe to say we have 0, minus 1, minus 3, which is equal to minus 4. So this is our determinant of matrix A. Are we okay with our determinant? Abdul Basit and Jemima, are we okay? Isabel?
Yes, sir.
Yes, sir.
Good. Now we're going to look for our cofactor. This is the formula for cofactor. C11, C12, C13, C21, C22, C23, and C31, C32, and C33. With a sign of plus, minus, plus, and then minus, plus, minus, and then plus, minus, plus. This is formula for cofactor. So now we have to look for C11, C12, C13, C21, C22, C23, and then C31, C32, and then C33, and substitute back into that cofactor matrices. So now in finding C1, we have to go back to our A matrices. But this time, when we are taking a value, we're not going to take the first digit from the column. We are not taking that anymore. We are only taking the values that are not hidden. So now let's start by finding I11. The 11 means row 1, column 1. 12 means row 2. 12 means row 1, column 2. So now we go back to our matrix A and look for the values. So now we are on matrix A and we are finding row 1, column 1, which is matrix 1, 1. What we are left with is 2 times 2, which is 4, minus 1 times minus 1, which is plus 1. So we have 4 plus 1, which is equal to 5. This is our matrix 1, 1. Then matrix 2, 2. Matrix 1, 2 is row 2, column. Sorry, 1, 2 is row 1, column 2. 1, 2 is row 1, column 2. This is 1, 2. So now we are left with minus 2 multiplied by 1, which is also a minus 2. Then minus 1 multiplied by minus 1, which is another minus 1. So we have minus 2, minus 1. No, sorry. We have minus 2 multiplied by 1 is minus 2, then minus 1 multiplied by minus 1, which is another minus 1. So minus 2 plus 1 is equal to minus 1. So the answer is -1. Then we go back to matrix 1, matrix 1, 3. 1, 3 is row 1, column 3. Row 1, column 3. So now we are left with 1 multiplied by 1, which is 1, minus 2 multiplied by 1, which is another minus 2. So our answer is 3. So we have 3 here. The next is matrix 2, 1, over to 2, 1. 2, 1. 2, 1. So mean row 2, column 1. Row 2, column 1. Now we are left with -2 multiplied by -1, which is 2, minus 1 minus 1 multiplied by 1, which is another 1. So we have 3. And then we have matrix of factor 2, 2. Row 2, column 2. Row 2, column 2. Row 2, column 2. So we have 0 minus 1, which is 1. Then matrix 2, 3. Matrix 2, 3. Matrix 2, 3. Matrix 2, 3 is going to be 2, 3. We are left with 0 minus 1, which is another 1. Then matrix 3, 1. Matrix 3, 1. Matrix 3, 1. So now matrix 3, 1 means row 3, column 1. We are left with -1 multiplied by -1 is going to give us 1. Minus 2 multiplied by -1, which is 2. We have -1 as the answer. So this is -1. Then for matrix C2, 3, 1. 3, 1 means row 3, column 1. Sorry, C3, 2, not 1. C3, 2. We have 0 minus 1, which is +1. And then the last, which is 3, 3. Row 3, column 3. We are now left with 0 minus 1, which is 1. So now we have to substitute it back to our matrix for factor, which is going to be, I am going to plane and substitute. Okay, I'll just substitute the answer near it, then we can proceed 1. For C1, we can see we have 1, 1, we have 5. For 1, 2, we have -1. For 1, 3, we have 3. For 2, 1, we have 3. For 2, 2, we have 1. For 2, 3, for 2, 3, we have 1. And for 3, 1, we have -1. For 3, 2, we have 1. And for 3, 3, we have 1. So the next thing is to apply the sign in our cofactor matrix. If you look at the sign in our cofactor, we have minus, plus, minus, minus, plus. The first in our first row we have plus, minus, plus. So we have to effect those signs to our values. So now let's do it. And that will be our cofactor matrix by effecting the signs. So by effecting the sign, the first one we have positive, so it will remain as 5. The second one is negative, therefore we have negative 1 with another negative will be 1. The next one is positive 3 and the 3 is positive, so it will remain as this. And if we look at the other one, here we have negative, so will be 3 negative. Here we have positive, will be 1, and here we have negative, minus 1. And then we have, here we have plus and minus is minus. And then minus is minus. And then we have plus is plus. So the next thing is to find the cofactor transpose. Cofactor transpose, remember this is cofactor of A. And the cofactor transpose of A is going to be, you make row to the column and column to the row. So now we're going to choose this row and make it column here. 5, 1, 3. We choose the second row, we make it column here, minus 3, 1, minus 1. And we choose this row and make it column here, which is minus 1, minus 1, and 1. So this is our factor transpose. The next thing to do is to find our inverse matrix, which is our A inverse, which is 1 over that A multiplied by cofactor transpose of A. Now we have all our required data. So all we have to do is to substitute. Our matrix is 1 over minus 4. If you can remember, our determinant is minus 4. We substitute. And our cofactor transpose is 5 minus 3 minus 1 and 1, 1 minus 1, and then 3 minus 1 and 1. So what do? We multiply. By multiplying, our A inverse becomes, we have 5 is going to be with the negative, with the minus 4, and here we have negative, negative with the positive 3 over 4, negative, negative with just 1 over 4. And the second row is going to be positive, negative, we're going to have negative 1 over 4. Positive, negative equals to another 1 over 4, and negative, negative is positive. It's going to be positive 1 over 4. And then here we have positive, negative, so it's negative 3 over 4. And then here is negative, negative, so it's positive 1 over 4. And here will be negative 1 over 4. So that will be our inverse matrix. And remember, for us to find our x, we have to multiply our inverse matrix with our B matrix. So the next thing to do is to multiply our inverse with our B matrix for us to get our x. Remember, our x is our I1, I2, and I3. And it's equal to A inverse multiplied by B, which is equal to our A inverse is 5 minus 5 over 4, 3 over 4, 1 over 4, minus 1 over 4, minus 1 over 4, and we have 1 over 4, then minus 3 over 4, 1 over 4, and minus 1 over 4. So we multiply it by the B matrix, which is 0, 0, and minus 10. So by multiplying, you remember, it's row by column, and row by column. So we can now see minus 5 over 4 multiplied by 0 plus 3 over 4 multiplied by 0 plus 1 over 4 multiplied by minus 10 over 4. Sorry, 1 over 4 multiplied by minus 10, which is going to give us, we're going to have our first answer for the first column as minus 10 over 4. So for the second row, minus 1 over 4 by 0 plus minus 1 over 4 by 0 plus 1 over 4 by minus 10. So we're going to have minus 10 over 4 again. And then for the last one, minus 3 over 4 multiplied by 0 plus 1 over 4 multiplied by 0 and minus 1 over 4 multiplied by minus 10, which is going to be positive 10 over 4. So we can say that our I1, I2, and I3 equivalent to, the first one is going to be minus 2.5 ampere, and the second one is going to be minus 2.5 ampere as well, and the third one is going to be positive 5 ampere. So we have found I1 to be 2.5 negative ampere, and I2 to be negative 2.5 ampere, and I3 to be positive 2.5 ampere. So now we're going to use a substitution method to solve for the same question. This is another alternative method that you can choose. For substitution, if you can remember, these are our equations. We have 0I1 minus I2 minus I3 equal to 0. And then the second equation was I1 minus 2I2 minus I3 equal to 0. And then I1 plus I2 minus 2I3 equal to minus 10. So now, if you look at the equation, it's only equation 1 that has just I2 and I3. The remaining two equations have all the three of those variables. So we can make these two equations look just like this by eliminating I1 in them. So how do we do that? We eliminate I1. We can say yes. We don't have to add anything to it, because I1 in equation 1 and I2 in equation 2 have the same coefficient. So what do? We just take subtraction. So we can say equation 2 and 3. So we can say yes, equation 2 minus equation 3. And we're going to have minus 2 minus 1 is going to be minus 3I2 minus 1I3, minus minus is plus, so we have minus 1 plus 2, which is plus 1I3, equal to 0 minus minus 10 is just 10. So we can call this our equation 4. So equation 4 and equation 1 are now of the same format, or look similar. So we can now say equation 1 and 4 by elimination. So we have minus I1, I2 minus 3 equal to 0, and minus 3I2 plus I3 equal to 10. So by eliminating I2, we can have multiplied by minus 3 and multiplied by minus 2. And therefore, we're going to be left with minus 3 multiplied by minus 1 is going to be 3 I3, which is equal to 0. And then minus 1 multiplied by positive 1 is going to be minus I3 equal to minus 1 multiplied by 10 is going to be minus 10. So by elimination, 3 minus I3 is going to give us 4I3 equal to 0 minus minus 10 is going to give us just 10. So we divide all through by 4, we have 10 over 4, which is equal to 2.5 ampere. By substituting this into our equation 1, our equation 1, remember, is minus I2 minus I3 equal to 0. So by substituting for I3 equal to 2.5, we have minus I equal to minus 2.5 equal to 0, which is equivalent to I2 equal to minus 2.5 ampere. Then by substituting into equation 2, we're going to have our equation 1. We're going to have our I1. And now we have I1 minus 2I2 minus I3 equal to 0. So by substitution, our I1 is now equal to, if we take the I2 and I3 to the other side of the equation, we have just 2 into 0.5 or plus 2.5. Oh, sorry. It's not going to be, it's minus 2.5. I3 is minus. So we have 5 negative plus 2.5, which is equal to minus 3.5 ampere. So are we okay? Hello? Are we okay? Say something. Camille, Victor, Omotola, Valerie. Are we okay?
Yes, sir.
So by substitution or matrix, you still arrive at the same thing, right? Hello?
Yes, sir.
So we have 30 minutes. So I'm going to introduce our next topic, and then we'll stop. So our next topic is going to be on DC network theorem. We are done with DC analysis. If you can remember, I have defined analysis and theorem for you and to all of you, and I believe each and every one of you can be able to differentiate between a theorem and analysis, right? Analysis is more like what? Use of some mathematical expression with assumption to achieve something. You're not very sure, you're only assuming. But for theorem, you have already, it's more like endpoint of analysis. You have already developed, modeled an equation that you can only use to what? Solve a problem. So you don't need to make an assumption anymore. So the theorem, under theorem, we have Thevenin theorem, which is a theorem developed by a scientist known as, Thevenin. And then we have a Norton theorem. Also, we also have a DC network transfer or power, maximum power transfer theorem, and we have superposition theorem. So today I would like us to take the first two theorem and solve a very simple question on it. Then we can continue on Thursday. So can we do that, or you're tired? If you are tired, we can leave it till Thursday. Hello? Do you have a class immediately after this? Isabel,
Yes, sir.
you have a class?
Yes.
By what time?
11.
Around
By
11.
11. Okay, so 23 minutes will not be enough. So we're going to stop here. On Thursday, we're going to start our new topic. Then, but I will send you the lecture notes so you can go through it before Thursday. Are we okay? We can stop here?
Yes, sir.
All right, good. So I don't think we have to sign attendance today. We'll just do it on Thursday.